we get too far into this video, check with your teacher to see if they want you to go ahead and watch this video. They may have already covered this in class and may want you to go ahead and skip this video and move on to the next one. But to be sure, check with your teacher before we go on. Alright, now that we've said that, what this video is going to look at is the 3 different possibilities that we're going to encounter when solving a linear equation. And as you can see the little thought reminder there, a linear equation are any equation where the highest degree is going to be 1. That's where your highest exponent value on any of the terms is going to be 1. So now that we've said that, let's look at the 3 different possibilities. The first we're going to look at is what happens when you have one solution. These are going to be the most prevalent problems that you will see and the ones that you'll run into the most often. So in example 5, we are going to follow our steps that we've been following, and we're going to distribute the -2 and the -4 through their respective sets of parentheses. So -2 times 18 is going to give me -16, and -2 times m will give me -2m. On the right side, -4 times 4 is going to give me a -16, and a -4 times a +6m will give me -24m. I then need to get the variables on the same side, since I don't have any like terms that I can combine that are already on the same side of the equation. So in the interest of keeping a positive variable, I'm going to add 24m to both sides. That will give me a -16, and then it will give me a positive 22m equals a -16. So the next thing I want to do is I want to get that m by itself. To determine whether I do the -16 first or the 22 first, I need to look at my order of operations. I am working backwards through the order of operations, so I want to get rid of that subtraction first. And I do that by adding 16 to both sides. So that's going to give me 22m is equal to 0. Now notice that we still do have a variable, so we need to go ahead and get rid of whatever's in front of that variable. In this case, it was being multiplied by 22, so we're going to divide by 22. So we end up with m equals 0. So whenever you have one solution, you'll end up with the variable equals some number. And that means you're going to have one solution. It might be 0, it might be 5, it might be 1,000. But as long as you get the variable equal to a number, you're going to have the one solution. So let's go ahead and look at no solution now in example 6. Alright, so we're going to follow our same process. We're going to multiply through the 4x and the 4 times 5. And that will give us 4x plus 27 equals 4x plus 20. Now in this one, when we try and get the variables on the same side, we're going to run into an issue. If we subtract 4x from both sides, that's going to cancel out and give me 0 plus 27. And on the right side, it's going to cancel out and give me 0 plus 20. So when I simplify and get rid of those zeros, that ends up with 27 equals 20. So you should by now realize that 27 is of course not equal to 20. There's nothing that we can plug into this equation to make it true. So because we end up with two numbers that are not the same, but that they're claiming to be equal to each other, we would say that this has no solution. So again, if we end up with two things that aren't true, like 2 equals 3 or 5 equals -5, it's going to end up with no solution. Our last step, example 7, we're going to look at infinitely many solutions. So this is going to mean that there are an infinite number of possible things that we could plug in and make this true. So we're going to multiply that 3 through, and that's going to give us 3x plus 21 equals 3x plus 21. Alright? So again, when we try and get things on the same side of the equation, we're going to run into a similar problem. Our 3x and our -3x are going to cancel and give me 0 plus 21. And on the right side, my 3x and my -3x are going to cancel out. And it's also going to give me 0 plus 21. Now simplifying this gives me 21 equals 21. The difference between this problem and the problem that we just worked is that 21 is actually equal to 21. That's going to be true. So no matter what we plug in for our x value, it's always going to give us two things that are equal to each other. No matter what we plug in for that x value. We could plug in 0, we could plug in 5, we could plug in 100. No matter what we plug, it's going to always end up to be a true statement. So we call that infinitely many solutions. And that is going to give you the situation we have in the middle of this chart here, where you get a number equals itself, or if you canceled out the numbers for some reason before the variables, you would end up with x equals x. Alright, so those are the three different combinations of possibilities you will run into as you're working through these problems. The most one that you're going to want to pay attention to is remembering that m equals 0 is actually a solution. A lot of people see that m equals 0 and they want to jump to the conclusion that it's no solution. You still have that variable, so it is going to be an actual solution. It's just the solution is 0. Alright, that wraps up this video. We have just one more video left in this lesson, so go ahead and attempt your you-try problems, and then join us in the next video. Alright, see you then.